Okay, welcome. Lesson number 2. This is all about the factorial notation, and it's a nice little button on your calculator that's an exclamation mark, and they call it factorial. So that means 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1 every time. So on my calculator, I could do 6 and then find the factorial button. So clear that out. 6, go to math, slide over to probability, and it's number 4, the exclamation mark. So 6 factorial is 720. Isn't that great? That shortens things up a lot, so we'll use that quite a bit. Down here, they have you simplify 6 factorial over 4 factorial. What if you weren't using your calculator? So you would write 6 times 5 times 4 times 3 times 2 times 1, but I'm just going to write 4 factorial at the end because I don't want to write out all of that, because I'm thinking on the bottom I have a 4 factorial, which means I know those are going to cancel out, and then I'll just times 6 times 5 together and I get 30. Over the page. Okay. Simplify the following expressions and leave in product form where appropriate. Here we go. I want to be able to cancel something on the top, something on the bottom, and I need to just think when I do factorial, I'm going to do my n, or whatever it is, times 1 less, times 1 less, times 1 less, times 1 less, until I get down to 1. So this is going to be n plus 2, and then 1 less will be n plus 1. 1 less is going to be n, and because I have that in the denominator, I'm going to quit. If I quit, I have to write the factorial. And now n factorial on the bottom. These two cancel, and my answer n plus 2 times n plus 1. I could FOIL that out if they wanted it, but that's going to be fine for now. Okay, B part. N minus 2, and then I'm going to think I'd do times minus 3 times minus 4 times, and that's not going to get anything for me to cancel on the bottom. So n minus 2 I'm going to leave with the factorial. Then n minus 1, 1 less is going to be n minus 2, and I'm going to quit factorial because now I notice I've got something on the top, something on the bottom, identical, and I'll be left with 1 over n minus 1. Okay, C part, let's think. N times n minus 1, yes, but I don't have a factorial on this. So I'm going to need to go one more. So n times n minus 1 times n minus 2 factorial over n minus 1. And now cancel, 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 and I'm left with n minus 2 factorial. Okay, next page. See how fun this is? Okay, now it gets better. Permutations. Here we go with some little stories. An internet site access code consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order. The order of the arrangement is important, and that you just need to get in your mind. So permutations means the order matters. John cannot remember the access code except that it contains 3, 5, and 7. List all the arrangements of these 3 digits that John could use to determine the access code. Okay, well, he could do 3, 5, 7, then he could try 3, 7, 5. What about if he put the 5 first? So 5, 3, 7, 5, 7, 3, 7, 3, 5, 7, 5, 3. By the time he tried those, probably he's been locked out. But we can see there are 6 different arrangements that he could try in order to get into the internet site. So total we'll have 6, but we can look at this in a few different ways. If I had my 3 little lines and I used fundamental counting principle, I could think my first number I had 3 choices to choose from, then I had 2 choices for the next, and 1 choice at the end left to choose, so 6 choices total. I could think of it as 3 factorial, which would give me 6 choices total, or with the permute button that we're going to do, I could have 3 permute 3. So in this formula, I've got n objects, and then permute, which means I will take and arrange, and then how many of them that will be taken and arranged. So I start with 3 numbers. I'm going to take and arrange all 3 of them, and that is also going to give me 6. Let's just do that on our calculator. So I've got 3, and then math, slide over to probability, and it's number 2. 3 permute 3. Enter. And ta-da! That gives me 6. So fundamental counting principle and this permute button and the factorial are going to be really helpful. Next page. So determine the number of permutations of the letters in each word. So if I have Regina, 1, 2, 3, 4, 5, 6 letters total, so I will have 6 ways to arrange, or 6 letters to pick from for the first, then 5, then 4, then 3, then 2, then 1, so 6 factorial, which if I put on my calculator, I will find that it's 720. Kelowna, 1, 2, 3, 4, 5, 6, 7. So I could do 7 factorial, or 7 times 6 times 5 times 4 times 3 times 1, or I could do 7 letters. I'm going to pick and arrange all 7 of them, and that's going to give me, so let's just do that one on my calculator. So 7 math, permute 7 equals 5040. Okay, they give you the general formula for that. That's on our formula sheet, and we'll be able to use that if we need it. Over the page. Defining 0 factorial. What you need to remember is 0 factorial is 1, and that's fine. So what happens is if we are doing 3 permute 3, for example, where the ends are the same, I know that'll be 3 factorial, and if I put it into the equation, I've got n factorial over n minus n in brackets factorial, which is going to leave me with a 0 factorial on the bottom. I know I need to have that n factorial as my answer, which means that denominator has to be a 1. Just remember, it's fine that 0 factorial is 1. Okay, and now let's do this next one. So this is going to show you that you can use fundamental counting principle or permutations on questions like these. And the helpful thing with this is it's a nice double check. These kind of questions in this chapter, you can trap yourself into thinking a whole bunch of things are correct, and it's nice to have a double check to see if they really are. So here we go. In a region, vehicle license plates consist of 2 different letters. So letter, and we're not repeating. Followed by 4 different digits. 3, 4 digits. And they are not repeating either. If the letters I, O, Y, and Z are not used, so then we've only got 22 letters of the alphabet available. Determine how many different license plates are possible using fundamental counting principle. Okay, so I've got 22 letter choices for the first one. I can't repeat whatever I chose, so I've only got 21 left. Then I need 4 digits, so my first digit, I've got 0 to 9, so 10 choices. I can't reuse, so I've only got 9 choices left. 8 choices, 7 choices. And if I multiply that all out, I end up with a nice big number. 2,328,480, which makes sense that we would have a lot of license plates available for people. Okay, now what if I do that using permutations? So here's what you're going to think. I've got these first 2 letters to choose and arrange to begin with. So I've got 22 letters. I'm going to take and arrange, or pick and arrange 2 of them. And so times, then I've got 10 numbers to choose from, or 10 digits to choose from. I'm going to pick and arrange 4 of those. And I put that on my calculator, and that will give me the same number. So 2,328,480. Yay! So, perfect double check if you're kind of uncertain about your thought process on either one of those ways. Last example, number 7. Algebraically solve the following. This is nice for an algebraic solve, and it just works with your algebra skills. But if you don't have to show it algebraically, you're just going to use guess and check to get the parts that you need and be able to use that digit. So we'll do it algebraically first, and then we'll do the guess and check so you can see how fast that is in comparison. Okay, here we go. So I'm going to end up putting this into my formula. So I look on my formula sheet, and I copy down n permute r is n factorial over n minus r in brackets factorial. Okay, let's substitute. So I've got n minus 1 in place of the n, so n minus 1 factorial over, and in place of the n again, n minus 1. Take away, my r is 2, all of that factorial. And this is supposed to equal 90. So 90 equals n minus 1 factorial over n minus 3 factorial. 90 equals, I'm going to think n minus 1, one last is n minus 2, n minus 3. Yes, I'm going to get something that can cancel out. So n minus 1 times n minus 2 times n minus 3. I can quit there. Factorial over n minus 3 factorial. Those will cancel. I get 90 equals n minus 1 times n minus 2, not factorial. I'm going to need to FOIL this out. So 90 equals n squared minus 3n plus 2. Move the 90 over so that it will equal 0 on the left side. So take away 90, take away 90, and I'm going to get 0 equals n squared minus 3n minus 88. Factors, n and n, 8 and 11 I'm hoping. Plus and minus, negative 11, yes. Plus 8, yes, gives me my negative 3n. So 0 equals n plus 8 n minus 11, which means n equals negative 8 or 11. And I realize, oh yeah, I can't have negative 8 objects, so this is extraneous. And my answer just ends up being the n equals 11. Okay, lovely for algebra, long if we don't need to do that. So instead, what I would do is I'm going to think, okay, I need something permute 2 that equals 90. So I'm just going to start on my calculator and go, okay, what about if I had 7 math permute 2 equals, oh, no, higher than that. How about 10? Math, permute 2 equals 90. Oh, that's it. 10 permute 2 equals 90. And then I look. Well, 10 is supposed to be n minus 1, which means my n better be 11. Much faster. Okay, that's all for this one. Isn't that great? Have a good time with these questions. You will love them, and we'll see you tomorrow.